Welcome everyone. In this video, I will be covering section 16.5, curl and divergence. Suppose F is a vector field in R3, define curl F. Curl F is given by partial derivative of R with respect to Y minus partial derivative of Q with respect to Z, I, plus partial derivative P with respect to Z minus partial derivative R with respect to X, J, plus partial derivative of Q with respect to X minus partial derivative of P with respect to Y, K. Is there an easy way of remembering this? Yes, we can remember this easily by taking the cross product of the gradient vector, del operator with F, vector field F, where F has components. The assumption here is F has components P, Q, R. So let's see how we get del cross F in the yellow highlighted way as a big expression like that. If we think of del as a vector with components dou by dou x, dou by dou y, dou by dou z, in order to give an idea about the C, you know that del F, gradient vector, if you remember how we define this, it is Fx, Fy, Fz. In other words, it is partial derivative of F with respect to X, partial derivative of F with respect to Y, partial derivative of F with respect to Z. So you can consider del as an operator with components, as a vector with components just dou by dou x, dou by dou y, dou by dou z. So del is a vector with components dou by dou x, dou by dou y, dou by dou z. We can also consider the formal cross product of del with the vector field F as follows. So what is cross product? If you remember the way we define cross product of two vectors, if you remember that, if I recap that idea, if you have the vector A with components A1, A2, A3, and B is another vector with components B1, B2, B3, then the cross product of these two vectors is a determinant where the first row is I, J, K. The second row is the components of vector A, and third row is the components of vector B. This is how we defined earlier in chapter 12. So del cross F, first row in the determinant is ijk. The second row are the components of del, which are dou by dou x, dou by dou y, dou by dou z. Third row are the components of F, which are P, Q, R. So if you expand this from the way we expanded earlier in chapter 12, the same method. So you go by the first row or first column. Let's choose the first row. Then when you go I, and then you have minus j and then positive k, you have to go in that order. So I times, you have to hide the column and the row to which I belongs. Then you'll be left with dou r by dou y minus dou q by dou z. Then you can write minus j, then left to right. So hide the column and the row to which j belongs. Then you are left with dou by dou x or dou by dou r by dou x, then minus dou p by dou z. Then you can write positive k vector, unit vector, hide the column and the row to which k belongs. You are left with dou q by dou x minus dou p by dou y. So if you look at this step and this step here, The ijk components are the same. I times dou r by dou y minus dou q by dou z. When we write z, j component, we can, if you make this positive, we make then this line, if you make j positive, then these two values will switch. So you'll have dou p by dou z minus dou r by dou x. Then k times dou q by dou x minus dou p by dou y. The two expressions that we have, namely this expression and this expression, are one and the same. So we can write um, curl f as del cross f. That's an easy way of remembering this result. Del cross f is same as curl f. So the easiest way to remember curl f is by the symbolic expression curl f equal to del cross f. Vector del cross vector f. And we will see another vector known as divergence div f, just known as divergence vector. Div f is dou p by dou x plus dou q by dou y plus dou r by dou z, which in short can be written as del vector dot f vector. So to prove that, if you take dot product of two vectors, for this same example, if you do dot product, you will multiply the corresponding components and add a1 b1 plus a2 b2 plus a3 b3, where a1, a2, a3 are the components of the first vector a, b1, b2, b3 are the components of the second vector b. So when you do del dot f, del has components dou by dou x, dou by dou y, dou by dou z. F has components p, q, and r. So the dot product of these two, del dot f, is obviously multiply the corresponding components dou p by dou x plus dou q by dou y plus dou r by dou z. So del dot f is div f. Observe that curl f is a vector field, but div f is a scalar field because it's a dot product. Div f is a dot product, so it's a scalar field. Curl f is a vector field because it's a cross product. You know that cross product is a vector. Dot product is a scalar. If F is the velocity field in a fluid flow, what are the physical interpretations of curl F and div F? At a point in the fluid, the vector curl F aligns with the axis about which the fluid tends to rotate. And its length measures the speed of rotation. Its length measures the speed of rotation. Div F at a point measures the tendency of the fluid to flow away or to diverge from the point. If F is a vector pi plus qj, obviously we are in 2 dimensions, is a vector field in R2, how do you determine whether F is conservative? We came up this idea earlier. And what if F is a vector field in R3? So how do you, in other words, how do you verify conservative, whether the field is conservative or not in R2 and in R3? If P and Q have continuous first order derivatives, and if you have the condition dou P by dou Y equal to dou Q by dou X, then F is conservative in R2. If F is a vector field in R3, if F is a vector field in R3 whose component functions have continuous partial derivatives and curl F equal to 0 vector, what is curl F? Curl F is same as del cross F. So if del cross F equal to 0 vector, if curl F equal to 0 vector, then F is conservative. So for two-dimension, the verification for conservative field is dou P by dou Y equal to dou Q by dou X. For a three-dimensional vector field, to verify whether it is conservative or not, you have to check whether curl F is a 0 vector or not. If it is a 0 vector, then F is a conservative vector field. So you might want to check the videos for the section 16.5 for problem number 7 and 13. Refer to the section videos. Let's try one problem for this video from the additional suggested problem. Let's try problem number 3. So problem number 3. Problem number 3, find A, the curl, B, the divergence of the vector field, f of x, y, z equal to x, y, e to the z, I, plus y, z, e to the x, k. So first let's try curl F. By definition, curl F is del cross, curl F is del cross F. So we'll use the determinant I, j, k. Then the components of del are dou by dou x, dou by dou y, dou by dou z. Then the components of F, which are PQR. So we notice here you have P, and this is the component of K, so it is R. So Q is missing, so which is equal to 0. So we can fill them up in the third row. XY e to the z, Q is 0, Y z e to the x. So we can either go by the first row or the first column. We'll go by the first row. I times, you cross multiply dou by dou y of y z e to the x minus dou by dou z of 0. Then I use plus j, then I have to go from right to left, which is dou by dou z, hide the column and the row to which j belongs. So you'll have dou by dou z of x, y, e to the z minus dou by dou x of y z e to the x. Then plus k times dou by dou x times 0 minus dou by dou y of x y e to the z. Now we expand I times, we're taking the partial derivative of yz e to the x with respect to y. So it will be z e to the x, and plus j dou by dou z of xy e to the z, is xy e to the z. When you partially differentiate with respect to z, x and y are constants. With respect to x, y, z, uh, y, z, you are differentiating with respect to x, that is y, z, e to the x, plus k, and then you have a minus sign here. With respect to y, xy e to the z, you are differentiating partially with respect to y. So it's going to be negative x e to the z. So rewriting curl f, L cross f, z e to the x I plus j times xy e to the z minus yz e to the x. Then, and we have minus x e to the z k. This is curl f. Then we will find divergence div f, which is by definition del dot f, which in other words is dou by dou x of p plus dou by dou y of q plus dou by dou z of r. That is dou by dou x of p is xy e to the z, then dou by dou y of 0, the q component is missing here, then dou by dou z of r, which is y z e to the x. So now you're differentiating this with respect to x, the first term. So that will be y e to the z. Then you're differentiating the last one with respect to z. So it's y e to the x. So you get y times e to the z plus e to the x. That is div f. So as I mentioned earlier, please refer to the problems from the additional, the section videos for section 16.5. Problem number 7 and problem number 13 are worked there. Hope this video helps, and see you next for my next video on 16.6.